So let's briefly recall the main elements of the two-fluid model. Within the two-fluid model, the dynamics of each fluid is given by a continuity equation. That is, the time derivative of the particle density is due to the particle flux. A momentum equation, which states that the time derivative of the plasma velocity is due to the forces that are acting on this fluid element. That is the electric force, magnetic force, pressure forces, and friction force. With d over dt, we have made the convective time derivative, that is, and the friction forces are given by the integral of the collision terms of Vlasov into Boltzmann equation. The pressure term is given by a closure equation that I am not going to write here. And the system has to be coupled to Maxwell equation that state that divergence of E is equal to rho over epsilon 0. Divergence of B is equal to 0. The curl of E is minus dB over dt. And curl of B is given by the current. And time derivative of the electric field. Charge density and current density are related to the two fluid quantities by fact that rho is given by the sum over all species of the charge of each species times ns, the density, and the current density is given by the sum over all species of qs, ns, and us. This is the two-fluid model that describes the dynamics of a plasma, taking into account the dynamics of electrons and ions and two different fluids.